Hello, students. I hope that all of you are fine in a good health. Today, inshallah, we are going to summarize the work which had been done within week 6, lesson 9.3, area of composite figures. By the end of this session, you must be able to find area of composite figures. Number 2, find the area of shaded region. Apply area of composite figures in real-life problems. First of all, we need to revise the math vocab, which is mainly composite figures. Composite figures are figures that are composed or made or consisted of two or more figures such as parallelograms, triangles, trapezoids, circles, or semicircles composed or connected together. How to find area of composite figures? It's better if you follow these steps. To find the area of composite figure, first of all, decompose the figure. Decompose the given figure into two shapes or three shapes which you already know the areas or the formulas of their areas. Number 2, you have to use the formula of each figure separated to find its area. Number 3, the area of composite figure is the sum of the or total of the areas. We will solve some selected exercises from your textbook pages 473 and 474. Exercise 1, page 473. Find the area of each figure. If necessary, use 3.14 for pi and round to the nearest hundredth. Look at this given figure. The given figure is composed of or made of a semicircle. The top or upper part is semicircle. And we already learned how to find area of semicircle before. Here is the semicircle, and the down part or the bottom is a square. Why this square, though it looks like a rectangle? Because both sides length is 12 yards. Step 1, we need to find area of a square. Side of a square is 12 yards. This is the given related to the square. So area of a square, write the formula directly. We cannot solve geometry without writing the formula. Area of a square equals side square, which is 12 square, and 12 square means 12 times 12, which is 144 square yards. And the second part is semicircle. The top of the composite figure is a semicircle. What is given related to the semicircle? The given here is the diameter D. This is D. And D equals 12 yards. And to find area of semicircle, we need to find R, which is the radius. R equals diameter divided by 2. R equals diameter divided by 2, which is 12 divided by 2 equals 6 yards. And directly write the formula of area of semicircle, which is half times pi times r squared. And because here pi is given 3.14, I'll convert the half into 0.5. So it will be 0.5 times 3.14 times 6 squared. And 6 squared means repeated multiplication, 6 times 6, which is 36. And I think most of you now memorized or know that 0.5 times 3.14 is directly 1.57 times 36 equals 56.52 square yard. Are we done, teacher? No. We found the two figures which are composite composited together, but we didn't find the whole composited area. So area of the composite figure, the whole figure, the whole blue area equals area of a square plus area of semicircle. This is area of the composite figure. Equals 144 plus 56.52 equals 200.52 square yard, and it's already to the nearest 100. Let's move to exercise 2. Exercise 2. In your book, page 473, find the area of each figure. The figure means the composite figure, the whole green area here. And it's very clear that it is consisted of two triangles, two right angle triangles composited together. So I'll call them triangle 1 and triangle 2. Triangle 1 this down and triangle 2 is up to avoid any confusion. And the given which is related to triangle 1 is the base is 4 feet and the height is 3 feet. And directly area of triangle, write the formula. Area of triangle 1 equals half b times h, which is base times height. It will be half times 4 times 3, and simply divide by 2 equals 1, and 4 divided by 2 equals 2. 2 times 3 is 6 square feet. Let's go to triangle 2. For triangle 2, its base is this red dashed line. It's 5 feet, and its height is 6 feet. So area of triangle 2, it's the same formula. Area of triangle 2, same formula of area of triangle 1, half times base times height, equal half times 5 times 6, and we can simplify. Divide by 2 equal 1, and divide by 2 equal 3, and 5 times 3 equal 15 square feet. Are we done, teacher? No, we still have step 3, which is area of composite figure. Area of composite figure equals area of triangle 1 plus area of triangle 2, which is 6 plus 15 equal 21 square feet. Let's move to exercise 3. It's a little bit different. Find the area of each figure, and the figure here is composite figure. Use pi equal 3.14. Very clear that we will not use pi in this question. There is no circle or semicircle. So ignore pi here. And round to the nearest 100. Let's take a look at this composite figure. The figure is composited of a trapezoid. Why trapezoid, miss? Because I can figure out the trapezoid by the two parallel bases. Trapezoid always have two parallel bases. So the down part is trapezoid. I'll find its area first and then move to the other part or other figure. The base 1 is 14 centimeter and base 2 is 7 centimeter, and height for this trapezoid is 6 centimeter. Directly write area of trapezoid. Memorizing the formulas is so important while learning geometry. Area of trapezoid equal half times b1 plus b2 times height, and we need to add b1 plus b2 first. It will be 21. Half times 21 times 6, and simplify to make the calculations easier. Divide by 2 equal 1, and divide by 2 equal 3. 3 times 21 is 63 square centimeter. And let's go to the second figure. The second figure is parallelogram. Parallelogram. Why? Because parallelogram has two parallel bases. Look at this base, two parallel sides. The upper part of this composite figure is parallelogram. How can I figure out the parallelogram? The parallelogram, in the parallelogram, each two opposite sides are parallel. These two sides are parallel. And the other sides, which are opposite to each other, also unparallel, unequal in measure. So again, in the parallelogram, each two, I'll draw small parallelogram here. Each two opposite sides are parallel and equal in length. It's kind of parallelogram. These are parallel and equal in length. These two sides also are parallel and equal in length, kind of. And area of parallelogram equals base times height. The base of parallelogram here is 10, and the height is the perpendicular line on the base, which forms 90 degrees here. It's 5 centimeter. It will be 10 times 5 equals 50 square centimeter. These are the areas of trapezoid and parallelogram which form the composite figure. And now we need to find the area of composite figure, which is the total or sum of the areas of the two figures, which is area of trapezoid plus area of parallelogram equals 63 plus 50 equals 113 square centimeter. Let's move to exercise 5. Exercise 5 is a little bit different. Find the area of each figure. If necessary, use pi equal 3.14, and we will not use pi here because there is no circle or semicircle. Look at these two figures. The two figures here are rectangle and triangle. If I look at the given here, the length of rectangle is 20 meters and its width is 6 meters. And if we close this part, it will be clear that this is rectangle. Area of rectangle equals length times width, which is 20 times 6 equals 120 square meter. And about the rectangle, look at the base of rectangle. Actually, we don't have any given related to the rectangle. We need to figure out. The base of rectangle is the blue line, which I drew just now. This is the base of rectangle. And to find the length of base of rectangle, we will subtract 20 minus the total of these together. The whole length here is 20, and the given parts is 8 and 6. So the rest of this line segment, which is the base of the triangle, is 20 minus 8 plus 6, which is 20 minus 14 equals 6 meters. So the base of triangle is 6 meters. What about the height? Look at the height. We can represent the whole dashed pink line on the figure using this. The length of all of this is 10 meters. The whole length here is 10 meters. But this part, this down part, which is width of rectangle is 6 meters. So the length of the height of triangle, this missing part, this question mark, is 10 minus 6 equals 4 centimeters. And write the formula of area of triangle, which is half times base times height equals half times 6 times 4. I'll simplify. Divide by 2 equal 1. Divide by 2 equal 3. 3 times 4 equal 12 square meter. Now we found the area of the two geometric figures which form the composite figure. We need to find the area of composite figure, which is the sum of these two areas together. Area of the composite figure equals area of rectangle plus area of triangle, which is 120 plus 12 equals 132 square meter. And now we will move to the second objective, which is how to find the area of the shaded region. To find the area of shaded region, we need first to find the area of entire figure or whole figure. And then find the area of the region that you will exclude. It means find the area of the unshaded part. And then subtract to find the area of the shaded part of shaded region. Let's go to exercise 7, page 473. Find the area of the shaded region. The shaded region here on my screen is the blue area. We need to find the area of the blue part or blue space or blue area. How will we do this, miss? Look at the whole figure. What is the whole figure? The whole figure here is rectangle. So even before looking at the shaded or unshaded area, find the area of the whole figure, first of all. What is the whole figure? It's rectangle. The length of this rectangle is 32 plus 8 equal 40 feet. And its width from the side, it's 8 feet plus 8 feet is 16 feet. And directly find the area of the whole figure. Its length times width, 40 times 16 equals 640 square feet. And now we need to find, we will move to step 2, which is area of the unshaded area. Area of unshaded region, which is the two small white squares here. We need to find this. Why, miss? Because the blue region, which is shaded, is it a specific geometric figure which we know its formula? No, teacher. So we need to find the area of a figure which I already know its formula. So area, we will find area of one square and then we will subtract the area of the two squares. So area of one square equals side square, which is side times side, and the side of one small square here is 8 feet. So 8 times 8 equals 64 square feet. And we need to subtract area of two squares. So I need to find area of the two squares. Area of two squares, they have the same side length. Both side lengths is 8. So area of the two squares equals 2 times 64 equals 128 square feet. And now I want to back to the figure again. We need to find the area of the shaded region. So I'll subtract the area of the white triangles from the area of the whole figure, which is rectangle, to get the area of the shaded region. It will be area of the whole figure, which is rectangle, minus area of 2 squares equals 640 minus 128 equals 512 square feet. And now we will apply area of composite figures in real life problems. This is applied question in your textbook, page 474. Alonso needs to sod his backyard. The figure shows the measurements of the area of his yard, which he intends to sod. One pallet of sod covers 400 square feet. How many full pallets of sod will Alonso need to have enough for his entire yard? As we used to do while solving the problem solving, I need to read it again to figure out what is given and what is required to find. Alonso needs to sod his backyard. The figure shows the measurements of the area of his yard. So the question directly gives you a hint to find the area, which he intends to sod. So directly, I have to think about area of composite figure, which is composited of rectangle 1 down and rectangle 2. And the question is about area. So I find area of rectangle 1, which has length of 50 feet and width 30 feet. And write the formula of area of rectangle. It's length times width equal 50 times 30 equal 1,500 square feet. This is area of triangle of rectangle 1. And then we will go to rectangle 2, the top one. Rectangle 2 has the dimensions 20 for length and 15 feet for width. Area of rectangle 2, same formula, length times width, which is 20 times 15 equal 300 square feet. This is step 1. Did I find the whole area of Alonso's backyard? No, miss, not yet. So I need to find the total area of the backyard, which is the area of the composite figure. Total area of the backyard will be, this is step 3, 1,500 plus 300 equal 1,800 square yards. And at this point, I need to read the question again. Alonso needs to sod his backyard. The figure shows the measurements of the area of his yard, which he intends to sod. One pallet of sod covers 400 square feet. Oh, one pallet covers 400 square feet. How many full pallets of sod will Alonso need? So if one pallet covers 400 square feet, one pallet covers 400 square feet. For the whole entire area, how many pallets do we need? This is the question. It means I'll divide the area of the composite figures into sods. I'll divide the whole entire composite area by 400. So it will be 1,000 divided by 400 equals 4.5 pallets. But the question, I'll be back to the question again. The question asks how many full pallets of sod will Alonso full pallets? So directly I cannot mention that the number of full pallets is 4. 4 is less than 4.5. Alonso cannot use it. He needs number of 4 pallets of sod, which is 5 pallets to cover the whole backyard. And he will find left, this is not a big deal. The question asks about how many full pallets of sod will Alonso need to have to cover the entire yard. Thank you very much. I hope that you got how to find area of composite figures, area of shaded region, and how to apply area of composite figures in real life problems. Thank you very much and good luck. Now you have to go to your textbook and solve the exercises one more time. Thank you very much.